Hi friends, today we're going to talk about graphing exponential functions by making a table. Our standard is sketch graphs of exponential functions and translate between graphs, tables, and symbolic representations. An exponential function, the standard form, is a times b to the x. Excuse me. A is the initial amount or the y-intercept. Since it's a y-intercept, we'll write it as a point, 0, comma a. And then b is the constant ratio. To find the constant ratio, we take any y value and divide it by the previous y value. So let's look here. Find the y-intercept, constant ratio, and whether the function is increasing or decreasing. I should talk about that quick. It's increasing if a is bigger than 1. Bigger than 1. And it's decreasing, not a, if b is bigger than 1. And it's decreasing if b is less than 1. So if we look here, again, it's in the form a times b to the x. So our initial amount here is a, and it's a y-intercept, so we're going to call it 0, comma 5. Our constant ratio is b, which is 0.5. And since 0.5 is less than 1, this is decreasing. Let's look at another one. A is 4, b is 1.2. So the y-intercept is a, 0, comma 4. The constant ratio is b, which is 1.2. And since 1.2 is bigger than 1, it is increasing. If we look here, we only have one number, so actually we're missing the a. This is the same as saying 1 times 0.75 to the power of x. So a is 1 and b is 0.75. So our initial amount, or our y-intercept, is 0, comma 1. Our constant ratio is 0.75. 0.75 is less than 1, so it is decreasing. All right, now we're going to graph these. We're going to graph it just by making a table. So we have to put these x values in for this x on our calculator and then see which y values we get back. So we're doing 2 times 0.6 to the power of x. We need to do that to the power of -2. If you're at home, you'll be using Desmos. So 2 times 0.6 to the power of, is this a to the b to the left of the 7 there, and we're doing -2. So to the power of -2, we get 5.55555. So we'll just call this 5.6. So -2, 5.6 is about right there. We'll do the same thing to the power of -1. I'm just going to delete my -2 and make it a -1. 3.3. So -1, 3.3 is right about there. Now we'll plug in 0. There we get 2. Plug in 1 is 1.2. Let me graph 0, 2 quick. 1, 1.2. And then finally, plug in 2. And we get 0.72. So that's right about there. As you can see, it's not a perfectly straight line, it curves. and it never quite touches the x-axis. We can continue it in both directions there. This is decreasing. We should know that because my b is less than 1. The initial value is 2. We can see that right there. All right, let's look at another one. 3 to the power of x. If I put these into my calculator, if I put -2 into my calculator, I would get 0.11. So 3 to the power of -2 is 0.11. We know that this one should be increasing. Remember, this is like 1 times 3 to the power of x. So my y-intercept should be 1, and it should be increasing. If I plug -1 in, I get 0.33. If I plug in 0, I get 1, which we knew that was going to be our y-intercept, again, because this is our a. If I plug in 1, I get 3. And if I plug in 2, I get 9. So again, we can see that it's kind of curved, but this time it's going up. Again, it's not going to quite touch our x-axis. Don't forget to put arrows. It does go on forever in both directions. I write 1/4 to the power of x. Again, this is like 1 times 1/4 to the power of x. If you prefer, you can call that 0.25. But I know my initial value is 1, and I know it's decreasing because b is less than 1. If I plug in -2, I get 16. That's not going to quite fit on our graph, so I'm not going to put that one on there. If I plug in -1, I get 4. If I plug in 0, I get 1, which we knew that was going to be our y-intercept. If I plug in 1, I get 0.25. And if I plug in 2, I get 0.0625. So that's just a little bit above the x-axis. We're going to go ahead and connect these. Put an arrow in both directions because it goes on forever. Alrighty, well that's all we have for you today. So again, some things to remember. We have to write A as a point because it's our y-intercept. And then B is increasing if it's bigger than 1, or the graph is increasing if B is bigger than 1, and decreasing if B is less than 1. All right, have a nice day.